The transformation of the global balance of naval power is rooted fundamentally in industrial capacity. To understand the expanding gap between the naval construction of China and the United States, we must look at the structure and composition of their respective shipbuilding industries. The raw data from the past 10 years reveals a divergence in the production of naval ships. In 2016, the People's Liberation Army Navy, which we will refer to as the PLA Navy, was already deep into a modernization phase, but the subsequent decade saw an unprecedented acceleration. Between 2016 and 2026, the PLA Navy grew from a force of 255 battle force ships to an active fleet exceeding 370 ships. During this exact same period, the United States Navy remained numerically stagnant, fluctuating narrowly between 275 and 290 battle force ships. The divergence is even more stark when evaluating the displacements of the vessels delivered. China did not achieve these numbers by churning out coastal patrol boats and small ships. The expansion was driven by the rapid serial production of large surface combatants and amphibious assault ships. The PLA Navy commissioned dozens of Type 052D destroyers, which are advanced multi-mission combatants equipped with large active electronically scanned array radars and a large 64-cell vertical launching system. They introduced the Type 055 large destroyer, a vessel displacing 13,000 tons and armed with 112 vertical launch cells capable of firing heavy anti-ship ballistic missiles. 10 of these massive Type 055 destroyers have entered service in 2 major production waves. At the same time, Chinese shipyards constructed 4 Type 075 amphibious assault ships, each displacing roughly 40,000 tons. Chinese naval shipbuilding achievements culminated in the launching and fitting out of the Fujian, a Type 003 aircraft carrier displacing over 80,000 metric tons and featuring an electromagnetic aircraft launch system. China is also working on its 4th aircraft carrier and its first nuclear-powered supercarrier. Meanwhile, the US Navy experienced persistent industrial bottlenecks. The transition to the Arleigh Burke-class Flight 3 destroyer, which integrates the new Spy-6 radar system, suffered from recurring design friction and construction delays. The Constellation-class frigates program, intended to rapidly deliver a proliferated medium surface combatant based on an existing European design, slipped years behind its original schedule before the lead ship could even be fully assembled. Most critically, the backbone of American undersea dominance faced severe structural delays. The Virginia-class nuclear attack submarine program, which requires a steady delivery rate of 2 hulls per year to maintain fleet requirements, dropped to an actual delivery rate of roughly 1.2 to 1.4 boats per year. Intelligence briefing from the Office of Naval Intelligence show that China possesses an estimated 23 million metric tons of total shipbuilding capacity, while the United States possesses less than 100,000 metric tons. This represents an industrial capacity differential of more than 200 times. This massive gap in production speed and volume is the direct result of the operating model of the shipyards themselves. The foundational reason China can construct naval vessels at this velocity is the dual-use nature of its shipbuilding industry. Beijing does not maintain separate industrial bases for commercial shipping and separate shipyards for military production, like what the US does. Instead, the 2 sectors Both naval and civilian are deeply integrated within the same corporate structures and the same physical shipyards. The state-owned mega-conglomerate China State Shipbuilding Corporation manages a vast network of shipyards that simultaneously dominates the global commercial market and build the PLA Navy. Today, China controls over 50% of all global commercial shipbuilding orders, building massive container ships, oil tankers, and liquefied natural gas carriers for international clients. In major Chinese facilities like Jianan Shipbuilding in Shanghai or Dalian Shipbuilding in the north, commercial hulls and cutting-edge warships are constructed side by side using the same dry docks, the same cranes, and the same underlying infrastructure. A visitor to these yards can observe a large container vessel being assembled in a dry dock, basically adjacent to a Type 052D destroyer or a Type 054B frigate. This dual-use architecture provides an immense economic and operational advantage. Shipyards are capital-intensive operations with massive fixed overhead cost. Maintaining giant gantry cranes, plasma steel cutters, automated welding lines, and expensive dry docks requires continuous financial capital. A Chinese dual-use shipyard distributes these fixed overhead costs across a massive volume of commercial projects. The commercial market subsidizes the infrastructure required to build naval warships. This makes the military vessels significantly cheaper to construct and ensures that the physical infrastructure is always maintained at peak operational readiness. In contrast, the US Navy operates in an entirely different and more vulnerable industrial ecosystem. The United States long ago ceased to be a significant player in global commercial shipbuilding, today accounting for less than 1% of global commercial output. As a result, American naval shipbuilders like Bath Iron Works in Maine, Ingalls Shipbuilding in Mississippi, and Newport News Shipbuilding in Virginia operate almost exclusively as bespoke military contractors. They have no commercial cushion to absorb economic shocks or to distribute infrastructure cost. In a purely military shipyard, overhead costs must be borne entirely by the state through defense contracts. They are entirely dependent on the fluctuating procurement cycles of their single customer, the Pentagon. When naval orders slow down, the shipyards face financial ruin or must drastically raise their prices to cover its fixed cost. In the worst-case scenario, they must lay off workers and reduce maintenance on the now redundant facilities. This negatively impacts the ability of American shipyards to maintain the capacity to build naval ships over time. The structural advantages of the Chinese dual-use model apply directly to human capital. Shipbuilding cannot be fully automated. It remains a labor-intensive craft that requires highly specialized skills, including precision structural welding, complex pipe fitting, electrical systems integration, and marine engineering. Because Chinese shipyards maintain a massive, continuous backlog of commercial orders alongside military contracts, they can offer stable, long-term employment to hundreds of thousands of industrial workers. A Chinese shipyard worker can spend several years welding the plating of a commercial oil tanker and then transition directly to assembling a Type 054A frigate. The fundamental mechanical skills of cutting, shaping, and joining heavy steel sections are highly transferable between commercial and military hulls. This continuous workflow creates an efficient pipeline for skill retention and labor scaling. Workers do not face layoffs when a specific naval program ends, because they can simply be reassigned to the commercial order book. This stability allows Chinese shipyards to run continuous, large-scale, on-the-job training, ensuring that institutional knowledge and technical proficiency are passed down seamlessly to new generations of workers without interruption. The American naval shipbuilding industry is the mirror opposite. American shipyards are trapped in a destructive boom-bust cycle. This instability is fundamentally driven by the way the United States Congress authorizes and funds defense procurement. The U.S. Navy relies on annual appropriations bills that are frequently delayed by political gridlock. The regular use of continuing resolutions rather than timely, predictable long-term budgets creates extreme financial uncertainty for shipbuilders. When Congress delays a funding block or reduces the procurement rate of a program like the Virginia-class submarine or the Arleigh Burke-class destroyer, the affected shipyards face immediate revenue shortfalls. Because they lack commercial contracts to fill the gap, they are forced to reduce shift, halt investments, and lay off skilled tradespeople. Once a highly trained marine welder or pipe fitter is laid off from an American shipyard, they rarely return to the defense industrial base. They migrate permanently to other industries, such as aerospace, manufacturing, or commercial construction, where employment is more stable and the working conditions are often less physically demanding. When Congress finally approves funding a year or two later, the American shipyards must start the labor cycle from scratch. They must aggressively recruit and train an entirely new cohort of workers. It takes years of hands-on experience for a new hire to achieve the same level of proficiency as the skilled workers they had previously laid off or had left. During this multi-year training period, shipyard productivity plummets, material waste increases, and construction schedules inevitably slip. The US Navy is locked in this constant and costly loop of hiring, losing, and retraining labor, while Chinese yards benefit from decades of workforce continuity. The industrial divergence extends far beyond the walls of the shipyards. A warship is a highly complex assembly of thousands of smaller systems, requiring specialized steel, propulsion, electrical switchboards, advanced sensors, and advanced weaponry. A shipyard is ultimately just a final assembly point. Its efficiency is entirely dependent on the robustness of its surrounding supply chain. China possesses a deeply integrated domestic manufacturing ecosystem that underwrites its shipbuilding sector. As the world's primary steel producer, controlling over half of global steel output, China can rapidly route naval-grade steel from domestic mills directly to adjacent shipyards. The supply chains for marine diesel engines, gas turbines, electrical cabling, and electronic components are located within the same regional industrial hubs as the shipyards themselves. Furthermore, under Beijing's strategy of military-civil fusion, technological advancements flow rapidly between the commercial and military sectors. If a Chinese commercial firm develops an advanced welding robot, a new composite material, or an efficient design software for commercial ships, that innovation is immediately adapted and deployed to the construction of naval combatants. The American defense supply chain, by contrast, is fragile, brittle, and fragmented. Decades of deindustrialization have hollowed out the manufacturing depth of the United States. The US Navy depends on a thin, specialized shred of suppliers, many of whom are single-source providers. For many critical components, such as structural castings, marine valves, propeller shaft, and radar systems, There is only one factory in the entire country capable of manufacturing the item. If something goes wrong for that single contractor, if they experience an accident, a labor strike, or financial problems, the entire naval shipbuilding line can grind to a halt. The lead times for these critical components are measured years in advance, so even small delays can stretch the timeline materially. We know about this because naval shipbuilders have attributed delays to problems with suppliers and contractors, in addition to insufficient training. The lack of industrial redundancy means that the American supply chain completely lacks the capacity to scale up production in response to greater naval requirements. It cannot borrow capacity from a broader commercial manufacturing base because that base no longer exists within the United States. Given the stark reality, a critical question emerges for defense planners. Can the United States replicate the Chinese approach to close this naval production gap? The strategic and economic consensus indicates that the answer is no. Rebuilding a globally competitive commercial shipbuilding industry in the United States is unfeasible under current global conditions. The cost of industrial labor, regulatory compliance, and market dynamics in the United States and barriers to entry in the global markets make American-built commercial vessels vastly more expensive than those constructed in East Asia. A commercial shipping company operating in the international markets will not pay a massive premium to buy an American-built cargo ship when they can purchase a high-quality vessel from China, South Korea, or Japan at a fraction of the price. The domestic commercial shipbuilding market in the United States is artificially sustained by the Merchant Marine Act of 1920, commonly known as the Jones Act. This legislation dictates that all vessels transporting goods between U.S. ports must be built in American shipyards, owned by U.S. citizens and crewed by U.S. mariners. While the Jones Act succeeds in preserving a bare minimum baseline of domestic shipbuilding capability, it has effectively insulated parts of the American shipping markets from global competition. It has created a small captive market that continues to put the small number of American commercial shipyards on life support. But this is ultimately destructive for competition and innovation in the American shipbuilding industry in the long term. To construct a commercial shipbuilding ecosystem that can rival China would require the US government to inject hundreds of billions of dollars in direct state subsidies over multiple decades. It would require an unprecedented overhaul of national industrial policy to sustain massive financial losses indefinitely. Even if such a policy were politically viable in a highly polarized political environment, American shipyards would still be competing against deeply entrenched and efficient shipbuilders in Asia that possess overwhelming structural advantage. The reality is undeniable. The rapid growth of China's Navy is an inevitable conclusion of its position as the world's preeminent shipbuilding nation. The PLA Navy builds its combatants as an extension of a globally integrated industrial engine. The US Navy builds its naval combatants in a low-volume, isolated, high-cost environment that is vulnerable to funding disruptions and supply chain disruptions. The structural asymmetry means that for the foreseeable future, China will retain the industrial capacity to outbuild the United States in overall naval tonnage. The United States cannot win a competitive race of pure industrial attrition by trying to match Chinese naval output ship for ship, using its current industrial architecture. The United States must abandon the expectation of numerical parity and instead focus heavily on its enduring areas of asymmetric advantage, for example, submarines and undersea warfare, and deeply integrating its operational planning with allies like Japan and South Korea, who possesses the substantial shipbuilding depth that the United States itself lacks.